Alright, my party people, let's look at how to graph quadratic functions. Step to graph a quadratic function. Number one, we're going to use negative b over 2a to find the, you guessed it, axis of symmetry. Now, what does the axis of symmetry share? It shares the x-coordinate of the vertex. So then step number two would then be to find the vertex, because we already had the x value. Now we would plug it in to find the y value of your vertex. Number three, we're going to use that vertex as the middle point in my table and find some other points on the graph. And then number four, we are going to graph those points, those puppies, and we're going to connect them to make a parabola, a U-shaped, right? The graph of a quadratic is called a parabola. Alright, so let's look at example number one. Example number one is the parent function f of x, or y, equals x squared. So again, step number one is to list out a, b, and c. A is the number in front of x squared, which in this case is 1. B is the number in front of the x term. And then c is the number at the end. And those are both 0. The axis of symmetry, again, is negative b over 2a. So we're plugging in what we know. We know that b is 0, so negative 0 over 2 times a, which is 1. Now, 0 divided by anything is, you guessed it, 0. So the axis of symmetry is x equals 0. Now, once again, that shares the x value of my vertex. So I know that the x value is 0 for your vertex. We're going to take that, we're going to plug it in, and then find what y is equal to. So 0 squared is 0. So guess what? Your y is also 0. So your vertex is at the point 0, 0. Plot that sucker right there. Now we're going to pick some points, okay, some x values, so that we can find some more points on the graph. Excuse me, we're going to pick some more x values so we can find some points on the graph. So let's pick negative 1. Okay, again, I'm going to plug this into here, and I'm going to find what y is equal to. So negative 1 squared. Negative 1 times negative 1 is a positive 1. So I have a point at negative 1, positive 1. Okay, well, I also know that the point symmetrical to that is this point right here, because this is your axis of symmetry. So that is a point away, that is a unit away, so then the other point has to be also a unit away. Let's look at negative 2. We're going to plug in negative 2 squared. So negative 2 times negative 2 is a positive 4. So negative 2, 1, 2, 3, 4. Same thing. 2 units away. So 2 units away over here would be the point positive 2, positive 4. This is the point 1, 1. So let's connect them. Let's make our parabola. The domain, oh man, the domain, all the x values. The domain is going to go from negative infinity to positive infinity. That arrow keeps going all the way to the left, so the graph starts at negative infinity. This arrow keeps going all the way to the right, so the graph ends at positive infinity. The range is the y value, so I'm scanning bottom to top. The graph starts right there at the vertex. The y value, because range is y's, range, the y value of the vertex is 0. So it starts at 0 and it goes to infinity. I could also write it like this. Y is greater than or equal to 0. Let's go to number 2. Number 2, same thing. List out a, b, and c. A is 1. B is the number in front of the x term. This is not b. Do not make that mistake. This is c. There is no x on this. So c is a negative 4. B is still 0. There is no b term. So once again, axis of symmetry is negative b over 2a. So negative 0 over 2 times 1. Once again, that's 0. So x equals 0. So I know the x value of my vertex is at 0. I'm going to plug that in to find the y value, because this f of x means y. So y equals x squared, but again, x is 0, so 0 squared minus 4. That gives me the point 0, negative 4. So I can plot that down 1, 2, 3, 4. There's your vertex. Now you also know that is your axis of symmetry. Right? So let's find another point. Let's just plug in positive 1. So I'm going to plug in positive 1 in place of x, so 1 squared minus 4. 1 squared is 1, minus 4 is a negative 3. So you have a point at 1, negative 3. We also know that we have a point at negative 1, negative 3. Because again, these have to be symmetrical. Alright, let's find another one. Let's say positive 2. Right, so I'm going to plug in 2 in place of x. So 2 squared minus 4. 2 squared is a positive 4. Minus 4, that's 0. So your intercept, x-intercept, is at 2, 0. Well, we also know, guys, that 1, 2 units away on the other side is the point that corresponds to that. So here's your parabola. It wants the domain. Well, once again, we're going from negative infinity to positive infinity. Or we could say all real numbers. And the range starts from here, which, again, the y value of your vertex is negative 4, and goes to positive infinity. Last one, we're looking at number 3. Okay, number 3, list out A, B, and C. A is negative 1, B is 2, and C is 3. Now, that negative right there, guys, will make the graph flip upside down. So we'll say that the parabola will open down. Right? So that negative in front of the x squared is going to flip the graph. It's going to make it an N instead of a U shape. The axis of symmetry is still negative b over 2a. So let's plug in our b. So negative 2 over 2 times the negative 1. So negative 2 over negative 2, x equals positive 1. Now, again, we know the the x value of our vertex shares that, so x is 1. So to plug in to find the y value, I've got negative 1 squared plus 2 times 1 plus 3. So 1 squared is 1, and that's a negative, so negative 1, plus 2 times 1 is 2, and then plus 3. So 5 minus 1 is 4. So the vertex is at 1, 2, 3, 4. Now let's find another point on the graph. So let's just, 0 is close to 1, right? So let's plug in 0. So 0 squared plus 0 plus 3. So I know that the y-intercept, because again, the y-intercept has an x value of 0, the y-intercept is at 0, 3. Okay, well we also found another point, right? Because again, this is your axis of symmetry, goes through the vertex. So another point that corresponds to that point is that point right there, which would be at 1, 2, 1, 2, 3. Alright, so let's plug in 3. Why not? So we're going to go negative x squared, so negative 3 squared plus 2 times 3 plus 3. Negative 3 squared plus 2 times 3 plus 3. 3 squared is 9, but again, that's a negative outside, so negative 9 plus 2 times 3 is 6, then plus 3. 6 plus 3 is 9. 9 minus 9 is 0. So you just found that your x-intercept is at 3, 0. Okay, well, once again, this is 1, 2 units away, so go 2 units this way. Plot that point. Well, that point is at negative 1, 0. So the other x-intercept is at negative 1, 0. Now we can connect those and make our parabola. You notice that it is opening downward. The domain is still negative infinity because it's still going to negative infinity, and it's still ending at positive infinity. Okay, or again, we could say all real numbers. But now the range changes, right? Because this graph keeps going down. So it starts at negative infinity. But it ends right here. It doesn't go above that point. So it ends at the vertex. Okay, well, what is the y value of your vertex? 4. There's your range. Or we could say that y is less than or equal to 4, right? Because all of my y's are below number 4 right there. Okay, so that's just a quick intro on graphing quadratics. See you next time.